Hi guys. All right. So there was a question on elastic collision. So this is an example. So this is number 6 on practice 2. Good. So this is an elastic collision. Okay. In this case, we have so same thing. Momentum in the before the collision is going to be equal to the momentum after the collision. Okay, so here we have it tells me that a 200 kilogram car is moving 8 meters per second east, and it hits a 1,000 kilogram car that is heading west at 5 meters per second. Okay, so here I have a car. I'm just going to draw a box, and it's moving 8 meters per second, and it weighs 2,000 kilograms. And then I have another car that is 1,000 kilograms, and it's moving this direction in it's moving west at 5 meters per second. Okay, so when I am doing this, I have to include my signs. So they collide, and then something occurs here. They say that the first car is slowed to 2.5 meters per second and bounces off this second car. So bounces off, that automatically tells us it's an elastic collision. And it's slowed, so it means it's still going in the same direction. And the second car, something occurs. So the second car, most likely, we don't know what direction it's going. So but we'll find that out with this specific problem. So here, so they crash. We have the first car, so the 200 kilogram car. Then is slowed down. It's still going in that direction at 2.75. What occurs? In which velocity is the 1,000 kilogram car then moving? That's what this is asking. So what is the velocity of 2 after the collision? Okay, so m1 v1 plus m2 v2 is going to equal m1 v1 plus m2 v2. Okay, so here they're not together, so we do not combine the masses. They're separate, so we take them as separate momentums. Okay, so the mass of the first one is 2,000 kilograms times the velocity, which is 8 meters per second. And then here, since the velocity is going in the opposite direction, it's going to be negative velocity. So I have plus 1,000 kilograms times a negative 5 meters per second is going to equal so 2,000 kilograms. So my mass of the first one, 2,000 kilograms. And I'm running out of space here. So I'm just going to have this equal. Okay, so it's going to equal essentially 2,000. 2,000 times 7.5 plus 1,000 times the final v2 velocity. So this is before the collision, this is after the collision. So before collision, after the collision. Okay, and they're both equal to each other. So let's work on the before side. So we have 2,000 times 8 is 16,000 kilograms per meter seconds, plus we have 1,000 kilograms times the negative 5, so negative 5,000 kilograms meters per second is going to equal 2,000 times 275, 2.75. That gives us 5,500 kilograms meters per second. And then we're adding, so plus 1,000 kilograms times V2. So we're solving for V2 in this case. All right, so here we have 11,000 kilograms meters per second is equal to 1,000 V2 plus 5,500 kilograms meters per second. So subtract by 5,500, just solve for V2. I got also 5,500 meters per second, and then divide that by 1,000. You should get 5.5 meters per second in the east direction. So check the Google Classroom for more videos, and also check your emails for any labs that are due. Again, all labs will be due tomorrow before 5 p.m. for electronic versions, and for hard copies, they are due before the class starts. Okay, if you have any other questions, go ahead and email me. Thank you.